The shoreline does not look like any shoreline that exists today. The water is shallow here, warmer than anything a modern ocean produces, and it runs in long flat sheets across red mudstone that has never been broken by a plough, never been named, never been mapped. The sky above it holds a sun that rises slightly differently than the one you know. The Earth's rotation is faster, the days are shorter, and the tidal pull of the moon is stronger because the moon itself is closer. This is not a ruined place. It is not yet a place at all, in the sense that nothing here has been claimed, bounded, or remembered. It simply exists, and it is about to be torn open. The year, if you can call it that, is somewhere around 200 million years ago. The single landmass that geologists would eventually name Pangea is in the last phase of its coherence. The ground beneath this shallow coastal plain is not stable, in any meaningful sense of the word. Deep below the red mudstone and the warm tidal flats, a system of mantle plumes, columns of superheated rock rising from the planet's interior, is pressing upward against the base of the crust, with a force that has no modern equivalent in human experience. Not a storm, not an earthquake, something slower and more absolute. The crust here is being stretched from below like a piece of leather pulled at both ends by hands that will not stop. There are animals on this shoreline, not mammals, not anything that looks like an ancestor of something you would recognise. Long-bodied reptiles move through the shallow water, hunting fish that have not yet evolved into anything that would survive the coming 100 million years. There are early relatives of the crocodilian lineage resting on the exposed mudflats, their scales dark and wet. There are insects, there is plant life along the higher ground, a kind of fern that grows in dense mats and holds the loose soil together with roots that go down perhaps 2 meters into the red earth. Everything alive here is alive in the only way it knows how to be alive, by responding to what is immediately around it. This shoreline will not exist in 50 million years. The ground it stands on will be thousands of kilometers away from itself, carried on a raft of continental crust moving at roughly the speed a fingernail grows, a few centimeters per year, until what was once a single connected body of land becomes 6 separate continents, drifting through an ocean that doesn't yet have a name. The word civilization appears in the title of this documentary, and that word deserves immediate attention. When most people hear it, they think of cities. They think of writing, of law, of grain storage and monumental architecture. They think of Mesopotamia around 5,000 years ago, or perhaps of the Indus Valley slightly earlier, or of the first Egyptian dynasties, or of the remarkable and still poorly understood sites that keep pushing the known boundary of organised human settlement further and further back. Göbekli Tepe in southeastern Turkey, built more than 11,000 years ago, before agriculture, before pottery, before anything that traditional archaeology described as the precondition for monumental building. The underwater structures off the coast of Japan at Yonaguni, the submerged land masses of the continental shelves that were dry during the last ice age, the anomalous precision of certain ancient megalithic alignments that no known civilization of their time should have been able to produce. These are not fringe curiosities. They are real physical objects, real archaeological sites, real geological formations, and they are part of what this documentary is about. But the split of Pangea, the actual rupture of the supercontinent, happened long before any of that. Long before the first primate, long before the first mammal, long before the asteroid that ended the non-avian dinosaurs 66 million years ago. So when this title says that Pangea split and took the first civilization with it, the claim being examined is not a simple one. It requires looking at what civilization might mean across deep time, at what the geological record actually preserves, at what the oldest human myths say about a world before the world, and at a body of scientific and alternative evidence that does not resolve neatly into a single answer. That is what the next 2 hours are for. Welcome. This is a channel for documentaries about the real history of the Earth, its ancient eras, and the civilizations that rose and fell across them. If you are settling in for the night or winding down from a long day, this is a good place to be. The topic tonight is long. It stretches across hundreds of millions of years of geological time and arrives at questions that are still actively debated among geologists, paleontologists, archaeologists, and a growing number of independent researchers who have been looking at the evidence from different angles. There is no need to rush through it. The pace here is steady. The story is strange enough on its own without any artificial dramatization. The promise of this documentary is this: to follow the evidence, geological, archaeological, mythological, and in places speculative but serious, from the moment the supercontinent Pangea began to fracture, through the deep time of the Earth's transformation, up to the earliest traces of organised human presence, and to examine honestly what those traces suggest about how far back the story of human complexity might go. The word civilization will be examined carefully, not treated as a fixed target. Because the more carefully you look at what that word means, the harder it becomes to say with confidence when it begins. The standard account, the one taught in school curricula across the English-speaking world, runs roughly like this. Modern humans, Homo sapiens, evolved in Africa somewhere between 300,000 and 350,000 years ago. For most of that time they lived as hunter-gatherers, moving across landscapes, following game and seasonal plant resources, using increasingly sophisticated stone tools, and eventually producing the extraordinary cave art of sites like Lascaux, Altamira, and Chauvet. Then, around 12,000 years ago, the climate shifted at the end of the last glacial maximum. The ice retreated, and in several places around the world, groups of humans began cultivating plants and herding animals. Agriculture led to surplus, surplus led to settlement, settlement led to specialization of labor, to hierarchy, to record keeping, to writing, and eventually to what we call civilization. The Sumerians of southern Mesopotamia are usually cited as the first example. Cities by 5,500 BCE, writing by 5,000 years ago, complex law and religion, and trade networks by 4,500 years ago. That account is not wrong as far as it goes. The problem is that it may not go far enough. The glitch, the place where the standard account begins to develop cracks, is not a single anomaly. It is an accumulation of anomalies that have been building for several decades in the scientific and archaeological literature, and they point in the same direction. They point toward the possibility that organised, complex human activity, and perhaps even something that deserves the word civilization, began substantially earlier than the conventional timeline allows, and some of the most serious evidence for that possibility is not archaeological at all. It is geological. It is written in the structure of the Earth's surface itself, in the places that are now underwater, in the continental shelves that were exposed dry land during the glacial maxima of the Pleistocene, and in the deep mythological memory of cultures around the world that speak with remarkable consistency of a great catastrophe in which an earlier world was destroyed by water and fire and the shaking of the ground. The geological event at the far end of this story, the actual splitting of Pangea, happened so far back in time that no human being witnessed it, no human ancestor witnessed it, no primate witnessed it. But the shape of the Earth that those early humans eventually inhabited, the shape of its coastlines, the depth of its oceans, the distribution of its continents, was the direct product of that splitting. The world that early civilization grew up in was the debris field of Pangea, and there is a serious argument to be made, one that this documentary will follow carefully, that the civilizational story encoded in human mythology and partially confirmed by archaeology is not merely the story of what happened after the last ice age. It is the echo of something much older, of repeated catastrophes, repeated destructions, and repeated beginnings, all of which trace back ultimately to the restless, still-moving geology of a planet that tore itself apart 200 million years ago and has not stopped moving since. The shallow coastal plain at the edge of the early rift, the one covered in red mudstone and warm tidal flats, is gone. It has been subducted, weathered, redistributed. The fern roots that once held its soil together are long since compressed into something unrecognisable. But the force that tore it open is still active. The mantle plumes are still rising, the plates are still moving, and the civilizations that built their cities on the edges of the resulting continents, near the coasts, near the deltas, near the shores of the seas that filled the gaps left by the splitting. Those civilizations were always, without knowing it, living on the surface of a planet in the middle of a geological process that began before life on land existed, and will not end before human civilization has run its full course, whatever that course turns out to be. That is where this documentary begins, with the ground itself, with what the ground is, what it does, and what it has already done to every attempt to build something permanent on its surface. Pangea was not always called Pangea. The name came late, coined in the early 20th century by a German meteorologist named Alfred Wegener, who noticed something that seems obvious once you see it, but that the scientific establishment of his time refused to accept for decades. The eastern coastline of South America and the western coastline of Africa fit together. Not approximately, not suggestively, but with the kind of precision that is difficult to explain as coincidence. The bulge of Brazil slots into the concavity of the Gulf of Guinea. The angular projection of the African continent's northwest corner corresponds to a matching indentation in the Caribbean coast. The shapes are mirror images of each other, separated by the South Atlantic Ocean, which is itself a relatively young body of water in geological terms, young meaning that it did not exist in anything like its current form until well after the Triassic period. Wegener published his hypothesis in 1912. He called it continental drift. He argued that the continents had once been joined in a single landmass and had since moved apart, and he backed this claim with evidence that went well beyond the matching coastlines. He pointed to identical fossil species found on opposite sides of the Atlantic, the same freshwater reptile, Mesosaurus, appearing in both Brazil and South Africa in rocks of the same age, in formations that could only have been laid down in the same body of shallow water. He pointed to matching geological formations, mountain ranges in Appalachia that continue with the same rock types and the same structural history in the mountains of Scotland and Norway. He pointed to evidence of ancient climates, coal seams in Antarctica that could only have formed in tropical forests, glacial striations in India and Africa pointing in directions that made no sense unless those landmasses had once been positioned much closer to the poles. The scientific community of his era dismissed him. The main objection was mechanical. There was no known force capable of moving continents. Wegener was right about the evidence and wrong about the mechanism, and in the closed logic of early 20th century geology, being wrong about the mechanism was enough to discredit the observation. He died in 1930 on an expedition to Greenland, still arguing for his hypothesis, not yet vindicated. The vindication came in the 1950s and 60s, when oceanographic surveys of the seafloor revealed the mid-ocean ridge system, a continuous underwater mountain range that circles the entire planet, running down the centre of the Atlantic through the Indian Ocean, around Antarctica and into the Pacific. At the crest of this ridge, new oceanic crust is being created continuously, as molten rock rises from the mantle, solidifies, and spreads outward in both directions. The older the oceanic crust, the farther it is from the ridge. The seafloor is a slow conveyor belt, moving the continents that ride on top of it. Wegener had been right. The mechanism was seafloor spreading. The theory that absorbed his work and the new oceanographic data became plate tectonics, and it transformed geology as completely as evolution had transformed biology. What plate tectonics revealed, among many things, was the full history of Pangea, not just its existence but its assembly and its breakup, both of which were part of a much longer cycle. Pangea was not the first supercontinent. It was, as far as the geological record allows us to determine, the most recent. Before Pangea there was Rodinia, assembled roughly 1 billion years ago and broken up around 750 million years ago. Before Rodinia there was Columbia, also called Nuna, assembled around 1,800 million years ago. And before that there are fragmentary records of even earlier configurations, going back to a time when the Earth's crust was so different in composition and behaviour that the word continent barely applies. The current best reconstruction of Pangea's assembly puts it together gradually over the Carboniferous and Permian periods, reaching its maximum coherence around 270 million years ago. At that point, essentially all of the Earth's continental landmass was gathered into a single connected body, surrounded by a single ocean called Panthalassa, meaning all seas, with a smaller embayment on the eastern side called the Tethys Sea. The Tethys is important because it is the ocean that would eventually shrink and close as India drove northward into Asia, throwing up the Himalayas in the process. Its remnants today are the Mediterranean, the Black Sea, and the Caspian. Pangea at its maximum was not a hospitable place in the conventional sense. The interior of a supercontinent of that size experiences climate extremes that no modern continent comes close to. With no ocean within thousands of kilometres, the interior received almost no moisture. The evidence from Permian rock formations in what is now central Russia and central North America shows desert conditions comparable to or more extreme than anything on Earth today. The coastal zones were more temperate, But even there, the single ocean of Panthalassa produced weather systems of enormous scale. Hypercanes, some researchers have suggested, storm systems far larger and more intense than any modern hurricane, generated by the vast unbroken surface of a global ocean with no land barriers to disrupt them. Life in the Permian, the last period before Pangea began to split, was dominated by the synapsids, a group of animals that included the ancestors of all modern mammals. Some of them were large. Dicynodonts, stocky herbivores with a pair of tusks and a beak, moved across the Pangean landscape in herds. Gorgonopsians, predators with long canines and a gait somewhere between a reptile and a large cat, hunted them. The early archosaurs, the lineage that would eventually produce the dinosaurs and the crocodilians and the birds, were present but not yet dominant. This was a world full of animal life, structured by evolutionary pressures that had been building for hundreds of millions of years, and it was about to be destroyed almost completely. The Permian Triassic extinction event, which occurred approximately 252 million years ago, is the largest mass extinction in the history of complex animal life on Earth. It is sometimes called the Great Dying. Estimates based on the fossil record suggest that somewhere between 90 and 96% of all marine species disappeared, and somewhere between 70 and 80% of terrestrial vertebrate species. The cause, or causes, are still debated, but the primary driver is widely accepted to be the Siberian Traps, an enormous volcanic province in what is now central Russia, covering an area of roughly 2 million square kilometers, which erupted over a period of approximately 1 million years straddling the Permian-Triassic boundary. The eruptions released quantities of carbon dioxide and sulfur dioxide sufficient to drive rapid global warming, ocean acidification, and the collapse of the marine food web. It is worth pausing on what 252 million years ago means in the context of this documentary. The Great Dying happened before the split of Pangea. The split was already beginning at the margins as the Siberian Traps were erupting, but the main rifting that would eventually produce the Atlantic Ocean and separate the continents into their current configurations happened later, primarily during the Triassic and Jurassic periods, between roughly 230 and 150 million years ago. The sequence matters. First the Great Dying, which reset nearly all complex life on the planet. Then, into a world of survivors and new evolutionary radiations, the breakup of Pangea, which reshuffled the geography of life so completely that species which had shared a single landmass now found themselves separated by thousands of kilometers of ocean, diverging along independent evolutionary paths that would never reconnect. The first major rift in Pangea opened in what is now the Central Atlantic region. A line of weakness in the crust running roughly north to south began to pull apart. Magma rose through the gap. The gap widened. What had been continuous land became a narrow seaway, then a broader channel, then an ocean. This process, the widening of the Central Atlantic, is ongoing. The distance between New York and Lisbon increases by approximately 2.5 centimeters every year. In the time it takes to listen to this documentary, those two cities will have moved about 4 micrometers farther apart. The human mind is not built to hold geological time comfortably. 200 million years is not a duration that can be felt or visualized. The best strategy is to use the Earth itself as a clock. When you look at the modern map of the world, the 7 continents, the Great Ocean Basins, the shape of the Mediterranean or the Red Sea or the Gulf of California, you are looking at the record of those 200 million years of motion. Every coastline is a scar, every mountain range is a collision, every ocean basin is a gap that opened after 2 pieces of crust were pulled apart by forces generated in the planet's interior. And every civilization that ever existed built itself on those scars. The Sumerians built in the delta of the Tigris and Euphrates, rivers fed by the Zagros Mountains, which were thrown up by the same collision of the Arabian Plate and the Eurasian Plate that closed the eastern Tethys Sea. The Egyptians built along the Nile, a river whose current course was shaped by the opening of the East African Rift, the same rifting system that may eventually split Africa into 2 separate landmasses. The Indus Valley civilization built on the floodplain fed by rivers descending from the Himalayas, mountains created by the impact of India, a fragment of the old Gondwana portion of Pangea, slamming northward into Asia at a speed that by geological standards was almost violent. None of those civilizations knew any of this. They knew the rivers, the seasons, the floods. They knew the soil and what it would grow. They did not know that the soil itself was the product of a 200 million year journey across the surface of a planet that had once been one thing and was now many. That knowledge came late, but the ground they built on carried the full weight of that history in its structure, in its chemistry, in the way it responded to rain and drought, and the slow changes of a climate that has never, in the full span of geological time, stayed still for long. The question of when the first civilization appeared depends entirely on what you mean by the word, and the way you define it determines not just the answer, but the shape of the entire inquiry. So it is worth spending some time on the definition itself, not as an academic exercise, but because the definition is where the standard account and the alternative evidence diverge most sharply. The conventional definition of civilization, the one built into most textbooks and most popular histories, requires a specific cluster of features: urban settlement, meaning populations concentrated in permanent locations at a scale large enough to require organised food distribution; writing, or some equivalent system of record keeping; a division of labour beyond the basic hunter-gatherer pattern of forager, hunter and elder; some form of governance or law; monumental architecture; long-distance trade. These features tend to appear together, and when they do, the result is what historians call a civilization. By this definition, the earliest known civilizations appear in southern Mesopotamia and the Nile Valley around 5,000 to 5,500 years ago, with possible earlier antecedents in the Indus Valley and in the Yellow River basin of China. The problem with this definition is not that it is wrong, it is that it is narrow in a particular way. It requires material evidence that survives. Writing survives if it is carved in stone or baked into clay. Monumental architecture survives if it is built from durable materials, in locations that are not subsequently flooded, eroded, or built over. Urban settlement leaves traces in the form of foundations, middens, and buried artifacts that can be recovered by excavation. But all of these survival conditions carry an enormous selection bias. They favour certain kinds of societies over others. They favour stone over wood. They favour high ground over coastal lowland. They favour dry climates over wet ones. They favour interior sites over the continental shelves that were exposed during glacial maxima and subsequently drowned when the sea level rose. The last glacial maximum, the peak of the most recent ice age, occurred roughly 21,000 to 26,000 years ago. At that time, so much of the planet's water was locked up in the continental ice sheets that global sea level was approximately 120 to 130 metres lower than it is today. That is not a small difference. 120 metres of sea level change exposes continental shelf areas of enormous extent. In Southeast Asia, the Sunda Shelf, the shallow seafloor between the modern islands of Sumatra, Java, Borneo and the Malay Peninsula, was dry land. It formed a landmass larger than modern India, sometimes called Sunderland, connecting what are now separate islands into a single continuous territory. In the Persian Gulf region, the Gulf itself was dry. The Tigris and Euphrates, together with the rivers draining from what is now Iran, flowed across an exposed plain and emptied into the Indian Ocean somewhere south of the modern Strait of Hormuz. In the North Sea, Britain was connected to continental Europe. In the area of the modern Bering Strait, a land bridge thousands of kilometres wide connected Asia to North America. All of that land is now underwater. It has been underwater for roughly 10,000 years, since the end of the last glacial maximum and the subsequent rapid rise of sea level that occurred as the ice sheets melted. The rate of that sea level rise was not uniform. There were episodes of rapid rise, sometimes called meltwater pulses, during which the sea could rise by several metres in a century, fast enough that communities living on low-lying coastal plains would have experienced the flooding of their territory within living memory, possibly within a single generation. If you accept the conventional view that civilization required agriculture, and agriculture was triggered by the climate change at the end of the Ice Age, then the civilizations that emerged in Mesopotamia and Egypt and the Indus Valley were doing so at exactly the moment when the coastlines of the world were moving. The low-lying coastal plains and river deltas that represent the most productive agricultural environments, the places with the richest alluvial soils, the most reliable water supplies, the easiest access to marine protein resources, were for thousands of years during the transition from glacial to interglacial conditions, being progressively inundated by a rising sea. Any settlements that had been established on those coastal plains during the glacial maximum, or during the early stages of sea level rise, would have been drowned. Their foundations are now sitting under 10, 20, 50, or 100 meters of ocean water. This is not speculation, it is basic physical geography. The question it raises is empirical, not philosophical. Were there settlements on those submerged coastlines? And if so, how complex were they? The answer is that we have fragmentary but real evidence that the answer is yes, and that some of it is considerably more complex than a scatter of hunter-gatherer campsites. Off the coast of northwestern India, in the Gulf of Khambat, formerly known as the Gulf of Cambay, sonar surveys conducted in 2001 detected what appeared to be the remains of a large submerged settlement. The site lies at a depth of roughly 30 to 40 meters, which corresponds to a sea level from approximately 9,000 to 10,000 years ago. The sonar images showed geometrically regular structures, what looked like walls, foundations, and what some researchers described as a grid-like street pattern. Dredging operations in the area recovered worked stone, pottery, and what were claimed to be human remains, though the provenance of these samples has been disputed because they were not recovered under controlled excavation conditions. The carbon dating of some of the organic material suggested ages of around 9,000 years, which would place the settlement at roughly the same period as the early phases of the Mehrgarh site in Pakistan, the oldest known predecessor of the Indus Valley civilization. If the Gulf of Khambat site is genuine, it would push the coastal phase of South Asian civilization back into a period that is almost entirely underwater and almost entirely unexcavated. That site is controversial. The sonar data has been questioned, the sample provenance is problematic, and no systematic controlled excavation of the seafloor at that location has been conducted. Acknowledging that is important. But the controversy does not make the underlying question go away. The question is, how much of the early story of human settlement was written on coastlines that are now submerged, and how much of that story have we simply never been able to read? A more widely accepted body of evidence comes from the analysis of sea level records themselves, combined with the distribution of known archaeological sites. When you plot the density of human settlement sites by age against the corresponding sea level maps, a consistent pattern emerges. The oldest known sites cluster on terrain that was, at the time of their occupation, relatively far from the contemporary coastline: inland sites, highland sites, cave sites. The coastal and lowland sites are systematically absent from the oldest periods, not because people didn't live there, but because those sites are underwater. Population geneticists studying mitochondrial DNA and Y chromosome lineages have consistently found signals of large coastal populations in the deep human past, populations whose archaeological traces should be abundant but are instead almost entirely missing from the record. The implication is not that civilization is older than we think in a vague, unspecified way. The implication is more specific, that the conventional archaeological record is a sample biased towards survival, and that the civilizational timeline we've constructed from it is almost certainly compressed at the early end, missing chapters that were written in places the sea has since reclaimed. This matters for the Pangea question, because of the geographical pattern it produces. The splitting of Pangea created the continental shelves. The geometry of rifting, the way the crust pulls apart and subsides at the margins, is what produces the wide, shallow coastal shelves that fringe most of the modern continents. Those shelves are the direct geological legacy of the breakup. They are the places where the rifted margins sank as the crust thinned and cooled after separation. And they are precisely the places that were exposed during glacial maxima and drowned during interglacials. The connection between Pangea's breakup and the flooding of early human coastal settlements is not metaphorical, it is physical. The geometry of the continental margins, the product of 200 million years of rifting, determined exactly which land was above water during human prehistory and which land was drowned when the ice melted. Standing on the shore of the modern Atlantic, somewhere on the coast of West Africa or the coast of Brazil, the water you see is filling a basin that was opened by the same process that separated those two coastlines from each other. The ocean itself is the scar of the rift, and somewhere on the floor of that ocean, at the right depth, in the right geological context, there may be the remains of things that people built when the water was not yet there. We have not looked carefully. The deep ocean floor is, in many respects, less well mapped than the surface of Mars. The continental shelves have been surveyed with increasing sophistication over the past 2 decades. but systematic archaeological survey of submerged shelf environments is still in its earlier stages, constrained by cost, by technology, and by a conceptual framework in archaeology that was built before the full implications of sea level change were absorbed into the discipline. The first civilization, if there was one, may not have left its best evidence on any currently accessible land surface. It may be sitting in the mud of a continental shelf, under water that is cold and dark and very deep, waiting for a technology that does not yet exist at the scale required to find it. The myths remember water. Across every major cultural tradition on Earth, in every inhabited region, in every language family that has been documented, there is a story about a flood. Not a local flood, not a seasonal inundation of a river delta, familiar and expected and managed. A flood that ended a world. A flood that rose until there was no high ground left or almost none. A flood that killed almost everyone, that erased what had been built, that forced a small remnant of survivors to start again from nothing on whatever fragment of land remained above the water. The Mesopotamian tradition carries several versions. The oldest written form comes from the Sumerian city of Nippur, where a text known as the Eridugenesis was preserved on clay tablets. In it, a man named Ziusudra is warned by the gods that a great flood is coming. He builds a boat. The flood lasts 7 days and 7 nights. When it subsides, Ziusudra opens a window in his vessel, and the sunlight falls on him, and he prostrates himself before the sun god Utu. The text is fragmentary. Large sections are missing, but what survives is enough to establish that the story of a survivor of a world-ending flood is among the oldest written narratives that humanity has produced. The Akkadian version is fuller. The man's name is Utnapishtim, and his story is embedded in the Epic of Gilgamesh, the great poem of ancient Mesopotamia that is itself among the oldest extended literary works known. In it, the god Ea speaks through the wall of a reed house to warn Utnapishtim of what is coming. The words pressed into the clay carry a weight that the passage of 4,000 years does nothing to diminish. Ea says, "Tear down your house and build a boat. Abandon your possessions and seek life. Bring the seed of all living things aboard. The boat that Utnapishtim builds is enormous. Its dimensions, described in the text, produce a structure that is essentially a cube, each side measuring 60 cubits, with 7 decks and 9 compartments on each deck." Whether those dimensions are literal or symbolic is a question the text leaves open. What it does not leave open is the nature of the catastrophe. When the flood comes, it comes with a violence that the text describes in terms of complete geological upheaval. The land shattered like a pot. The storm bellowed like a bull. The gods themselves were frightened. When the waters recede, Utnapishtim's boat comes to rest on a mountain. He sends out a dove, a swallow, and a raven. The raven does not return. He opens the hatch and looks out, and the light falls on his face, and he weeps. He makes offerings. The gods gather around the offerings like flies. And then the question that drives the rest of the narrative: why did you survive when everyone else died? What does it mean to be the last one? What do you do with the memory of a world that no longer exists? These questions are not decorative. They are the functional core of the flood narrative in every culture that carries it. The Akkadian version, the Sumerian version, the Hebrew version preserved in Genesis, the Greek version in which Deucalion and Pyrrha survive the flood sent by Zeus, the Hindu version in which Manu is warned by a fish that grows into the great fish Matsya and is carried by it to safety on a northern mountain, the Aztec version, the Andean version, the Aboriginal Australian stories of the rising sea that swallowed the coastal lands. All of them share this structural core. A world existed. It was destroyed by water. A few survived. The world they rebuilt was not the same as the world that was lost. The geographical spread of flood myths has been noted and catalogued for more than a century. The conventional explanation offered by mainstream anthropology is that flood myths are a natural cultural response to local flooding events, river floods, coastal storm surges, tsunamis, and that their universality reflects the universality of flooding as a human experience, not a shared memory of a single global event. That explanation has the advantage of being parsimonious. It requires no unusual event, no globally shared catastrophe, no ancient civilization that preceded the known record. Flooding happens everywhere. Of course, people tell stories about it. The difficulty with this explanation is that most local flood stories don't look like the narratives described above. a local flood story tends to be specific about its geography, its cause and its scope. A river overflows, a dam breaks, a storm surge hits a particular coast. The stories that have survived as the great flood myths of the major cultural traditions are different in kind. They describe not a local disaster but a total one. They describe the end of a world, not the flooding of a valley, and they are remarkably consistent in their structural details across cultures that had no known contact with each other. The Mesopotamian and Hebrew versions are understandably similar. They draw on the same cultural pool. But the structural similarity between those versions and the Hindu Manu story, and between both of those and certain Mesoamerican flood traditions, is harder to explain as independent invention. There is a geological context for global-scale flooding that the conventional explanation tends to understate. The meltwater pulses of the deglaciation period, episodes of rapid sea level rise following the last glacial maximum, were real events, well documented in the geological record. The most significant of these, sometimes called meltwater pulse 1A, occurred approximately 14,000 to 14,500 years ago. In a period estimated at no more than 500 years, possibly much less, sea level rose by somewhere between 16 and 25 metres. The current best estimates suggest that the rate of rise during this pulse was somewhere between 4 and 5 metres per century, with some models suggesting peak rates even higher. 4 metres per century sounds slow, but for a community living on a coastal plain with a slope of 1 metre per kilometre, a typical shallow coastal gradient, 4 metres of sea level rise translates to 4 kilometres of coastline retreating inland in a century. Within a single human lifetime, the shoreline that a person was born beside could be 4 kilometres behind the water. That is what the flood myths are describing, in the language available to the people who experienced it. They are describing a world in which the land they had always known was being swallowed by the sea, year by year, generation by generation, until the place that had been home was gone, and the survivors, the people who moved to higher ground, who watched the water take everything, carried the memory of what had been lost into a new world that had no room for it except in story. The Dogon people of Mali carry a tradition of a homeland across the water. The Dravidian traditions of southern India contain references to a land called Kumarikandam, a great southern continent that was swallowed by the sea, from which the ancestors of the Tamil people are said to have come. The traditions of the Yolngu people of northern Australia include detailed accounts of the flooding of the coastal plains that are now the shallow seas of the Sahel Shelf, accounts so specific in their geographical detail that, when marine geologists examined them alongside sea level maps, the correspondence was striking enough to be published in scientific literature. Those traditions describe individual features, inlets, headlands, islands, that exist today as underwater formations at the depth corresponding to the sea level of 10,000 to 12,000 years ago. The traditions preserve the geography of a coastline that has been underwater for roughly 10,000 years. That last point deserves emphasis because it challenges a widespread assumption about how oral traditions work. The common assumption is that oral traditions degrade rapidly, that stories passed down through generations accumulate errors, embellishments, and distortions that make them unreliable as historical records after a few centuries. That assumption may be correct for many types of information. But geographical information, the shape of a coastline, the location of a freshwater source, the direction of a current, tends to be preserved with unusual fidelity because it is practically useful. A community that knows where the freshwater springs are, where the fish aggregate, where the safe harbours lie, passes that knowledge down with precision because precision is survival. When that community's coastline is flooded, the geographical knowledge becomes sacred, encoded in myth, because it can no longer be verified by walking to the shore and looking. The Australian case is particularly well documented because the correspondence between the oral traditions and the submarine topography is specific and verifiable. But the principle it illustrates is general. If flood memories were preserved with geographical precision in a culture that had no writing, then the written flood narratives of Mesopotamia and India and the Mediterranean world may contain similarly precise information about the geography of a world that no longer exists above the waterline, embedded in the symbolic language of myth. The scribe of Nippur who copied the flood narrative onto wet clay in the 2nd millennium BCE was not inventing the story. He was copying it from an older source, which had been copied from an older source still. The tradition he was preserving extended back through layers of transmission that he could not count. What he wrote begins this way. After the flood had swept over the land, and after kingship had descended from heaven, the first cities were built. Eridu was first, then Bad Tibira, then Larak, then Sippar, then Shurupak. These are the cities that tradition said existed before the flood. The flood swept over them. After the flood, kingship descended again, and the cities were rebuilt. The Sumerian king list, one of the most remarkable documents of the ancient world, carries this structure explicitly. Before the flood, it says, kings ruled for impossibly long periods, 28,800 years, 36,000 years, 43,200 years for a single reign. After the flood, the reigns become shorter, still very long by any realistic standard, but trending toward durations that eventually become historical. The standard interpretation of the pre-flood reigns is that they are mythological, that the numbers are symbolic, astronomical or liturgical rather than literal. That is almost certainly correct, but the structural claim the king list is making is worth taking seriously. That there was a world before the flood, that it was organized, that it had cities and rulers, and that the flood ended it. The cities it names, Eridu, Shurupak, are real sites that have been excavated and that show occupation layers going back to the 6th and 5th millennia BCE, with flood deposits in their stratigraphy that correspond to a real flooding event in the ancient Mesopotamian archaeological record. The world the king list remembers may be partly real, partly mythologized, and partly a projection of later political structures back into a legendary past. Most ancient historical traditions are all three simultaneously, but the fact that the real archaeological sites carry real flood deposits, that the ground itself confirms the water, means that the myth is anchored to geology in a way that cannot be dismissed as pure invention. The site at Göbekli Tepe sits on a ridge in southeastern Turkey, about 15 kilometers northeast of the modern city of Şanlıurfa. The ridge is not a natural feature in the way that a mountain or a river valley is a natural feature. It was made, at least in part, by the people who built there. The mound that covers the oldest and most extraordinary structures is composed almost entirely of deliberately deposited fill. The builders buried their own work, layer by layer, over a period of centuries, filling in each completed enclosure with rubble and soil before constructing the next one above it. The effect is that the oldest structures are also the deepest and in several ways the most sophisticated. The site runs backward in time as you go down. The enclosures that have been excavated, and only a small fraction of the total site has been opened, consist of rings of T-shaped limestone pillars, some of them up to 5.5 meters tall and weighing between 10 and 20 metric tons. The pillars are not raw blocks, they are shaped. Their surfaces carry carved reliefs of animals: foxes, boars, cranes, scorpions, lions, snakes, ducks, and at least one representation of what appears to be a vulture holding a sphere. The two central pillars in each enclosure are larger than the surrounding ring pillars and carry additional carved detail on their broad upper faces, what appear to be arms and hands, suggesting that these pillars are not purely abstract architectural elements, but representations of beings. Human beings, perhaps, or something the builders imagined as human-like. The dating of Göbekli Tepe is well established. The oldest layers at the bottom of the mound have been dated by radiocarbon methods to approximately 9,500 to 10,000 BCE. That is, roughly 11,500 to 12,000 years ago. This places the construction of the deepest enclosures at or slightly before the very end of the last glacial maximum, at the beginning of the Younger Dryas period, or in some estimates just after it. The Younger Dryas was a sudden cold reversal that interrupted the general warming trend of the deglaciation, a period of roughly 1,200 years, from approximately 12,900 to 11,700 years ago, during which temperatures in the northern hemisphere dropped sharply and conditions briefly returned to near glacial severity before the final warming resumed. The standard account of who built Göbekli Tepe identifies them as hunter-gatherers. There is no evidence at the site of permanent habitation, no hearths arranged for domestic living, no grain storage, no animal pens. The people who quarried and carved and erected those pillars were, by the conventional interpretation, nomadic or semi-nomadic groups who came together at this ridge for ritual or ceremonial purposes and then dispersed. The site is interpreted as a sanctuary, a gathering place, a centre of symbolic and religious activity that preceded settled life rather than following from it. The conventional sequence, settlement first, then monumental building, is inverted at Göbekli Tepe. The monument came first. The settlement, in the form of the early Neolithic villages of the surrounding region, came later. This inversion is significant. It suggests that the organisational capacity required to plan, quarry, transport and erect multi-ton stone pillars did not require the surplus economy of agriculture to generate it. It required coordination, planning across time, the ability to direct labour toward a purpose that was not immediately subsistence-related, and the transmission of technical and symbolic knowledge across generations. Those are cognitive and social capacities. They do not leave the same kind of archaeological trace as grain pits and pottery kilns, but they are present at Göbekli Tepe in the form of the pillars themselves, and those pillars are 12,000 years old. The question that Göbekli Tepe forces is not just about the site itself, it is about what came before it. The enclosures at the bottom of the mound are the most technically accomplished, the largest pillars, the most refined carvings. The upper layers, which are later in time, show smaller pillars and somewhat less refined execution. The conventional explanation for this pattern is that the site was going out of use, that the community that built the lower enclosures was a peak expression of a regional tradition that subsequently declined. That may be correct. But there is another reading, that the people who built the bottom enclosures were not at the beginning of their tradition. They were somewhere in the middle of it, or near the end. The refinement of the lower layers suggests accumulated technical knowledge, not beginner's work. If you're seeing peak execution at the base of the site and declining execution as you go up, the tradition that produced the peak execution did not begin at Göbekli Tepe. It arrived there. Where it arrived from is the question. The surrounding landscape in the period of 12,000 years ago was in transition. The Younger Dryas had created harsh conditions across the Near East, cold, dry, with vegetation zones compressed and animal populations stressed. But before the Younger Dryas, in the brief warm period of the Bölling-Alerud interstadial that preceded it, the Near East had been relatively productive, and before that, during the depths of the last glacial maximum, the coastal populations of the eastern Mediterranean and the Levant had been living on a coast that no longer exists, a coastline that stood well below the current sea level on the exposed shelf of what is now the eastern Mediterranean seafloor. When the sea level rose and those coastal territories were flooded, the populations that had lived on them moved inland and upland. Some of them carried their technical traditions and their symbolic systems with them. The pillar-building tradition at Göbekli Tepe may be the inland expression of a coastal culture that was displaced by rising water. The sophistication of the work argues for a long tradition behind it. The location, a ridge, high ground, conspicuously not coastal, argues for a community that had reason to value high ground in a way that a population which had never experienced flooding would not necessarily share. This is a hypothesis, not a proven sequence, but it fits the pattern of evidence and it fits the mythological memory. The flood came. The people moved to the hills. On the hills they built. The site at Göbekli Tepe was not alone. As survey and excavation across the broader region of southeastern Turkey and northern Syria has expanded in recent decades, the number of sites showing comparable characteristics, T-shaped pillars, carved animal reliefs, ritual enclosures without domestic occupation, has grown steadily. Karahan Tepe, roughly 35 kilometers southeast of Göbekli Tepe, shows structures of comparable age and some features that, in their technical execution, rival or exceed those of the better-known site. The pillar figures at Karahan Tepe include representations that are more explicitly humanoid than anything at Göbekli Tepe. Pillars carved to resemble figures emerging from the rock face, with rib cages, arms and faces partially defined. The effect is somewhere between architectural element and sculpture, and it suggests a symbolic vocabulary that was being actively developed and refined across multiple sites in the same region during the same period. Taş Tepeler is the collective name now given to this cluster of sites, a term meaning stone hills in Turkish. Surveys suggest that there may be dozens of such sites across the region, most of them still unexcavated. The pattern they collectively form is not that of a single, special-purpose monument isolated in a landscape of simple hunter-gatherer campsites. It is the pattern of a regional tradition of monumental construction distributed across a territory, maintained over centuries, and expressing a consistent symbolic system. That is not what a society at the very beginning of complex social organisation looks like. it looks like a society with history behind it. The question of what that history was, where it came from, how long it ran, what its geographical extent was before it became concentrated at these highland ridge sites, is genuinely open. The submerged continental shelves of the eastern Mediterranean and the Levantine coast cannot be excavated with current technology at the scale that would be needed to answer it. What lies on the seafloor of the eastern Mediterranean at depths corresponding to the sea level of 12,000 to 20,000 years ago is largely unknown. Small-scale survey work in various locations around the Mediterranean basin has found submerged structures and worked stone in shallow coastal waters. Nothing yet that constitutes proof of a complex civilization, but enough to confirm that people were living on those coastal shelves and leaving traces there. The connection back to Pangea runs through the geometry of those shelves. The eastern Mediterranean basin exists because the African plate and the Eurasian plate have been converging since the closure of the Tethys Sea, a process that began when the northern edge of Gondwana, the southern portion of Pangea, began breaking away. The Levantine coast, the shelf of what is now Lebanon and Israel and the Gaza coast, and the northern Sinai, is sitting on crust that was shaped by millions of years of tectonic interaction between those two plates. The shelf geometry, how wide it is, how steeply it slopes, how far it extended when sea level was lower, is the direct product of that tectonic history. The places where early coastal populations could build their settlements were defined by the shape of a continental margin that Pangea's breakup had been sculpting for 200 million years. The early inhabitants of those coastal shelves did not know any of this. They knew where the fish were. They knew where the fresh water ran down from the hills to the sea. They knew the seasonal patterns of the coast, the storm directions, the behaviour of the tides. They built what they could build with the materials available: wood, reed, mud, and in places where good stone was nearby, stone. And when the water came for their world, they took what they could carry and they moved uphill. And eventually some of them built enormous carved pillars on a ridge in southeastern Turkey, and the pillars are still there, and the sea that took their first home is still there too, and the shelf it covers is the same shelf that Pangea's breakup created. The floor of the ocean is not featureless. That is one of the things that deep-sea mapping has made clear over the past several decades, and it is relevant to the question this documentary is examining. The seafloor is a landscape. It has mountains and valleys, plains and canyons, ridges and basins, and in the shallower zones of the continental shelves, it has the preserved topography of a terrestrial world: river channels, lake beds, coastal dunes, estuarine deposits, that was above water during the last glacial maximum and was drowned as the ice melted and the sea rose. The North Sea is one of the best studied examples. During the last glacial maximum, the North Sea basin was dry land. The Thames, the Rhine, the Meuse, and the Scheldt all converged on this exposed plain and flowed north together into what is now the Norwegian Sea. The combined river system has been named Doggerland by researchers after the Doggerbank, the shallow underwater plateau in the middle of the modern North Sea that is its most prominent remnant. Doggerland at its maximum extent was a territory of perhaps more than 100,000 square kilometres, roughly the size of England. It had a landscape of river plains, wetlands and forested uplands. It had animals, mammoths in its earlier phases, then as the climate warmed, elk, aurochs, wild boar and beaver. It had people. Fishing gear, harpoons, worked wood, and human remains have been dredged from the North Sea floor by fishing boats and research vessels for more than a century. The people who lived in Doggerland were Mesolithic, skilled hunters, gatherers, and fishers who used watercraft to navigate its rivers and coastal waters. Doggerland was not drowned all at once. The sea level rise that followed the last glacial maximum was gradual over most of its duration, measured in centuries. But around 8,200 years ago, a catastrophic event accelerated the final submersion of the remaining dry areas. An underwater landslide off the coast of Norway, the Storegga Slide, displaced an enormous volume of ocean water and generated a mega tsunami that swept across the North Sea with waves estimated at several metres to possibly more than 20 metres in height in some coastal areas. The timing of this event corresponds closely to evidence of rapid coastal abandonment in several Mesolithic sites around the North Sea rim. The people who survived the tsunami on the remaining low-lying parts of Doggerland would have found their world abruptly and permanently changed. Any high ground that remained above water after the tsunami would have been isolated as islands within a few more centuries of continued sea level rise. By 7,000 years ago, Doggerland was essentially gone. The people of Doggerland left no written records. They left worked flint, antler tools, a fragment of a wooden paddle, and the occasional human bone in the cold sediment of the North Sea floor. But they lived in that landscape for thousands of years, and their descendants merged into the populations of Britain and continental Europe that eventually built the megalithic monuments of the Atlantic facade, the great stone structures of Brittany, of Ireland, of Wales and Scotland and the Orkney Islands. Carnac in Brittany, with its thousands of standing stones arranged in long parallel rows across several kilometres of landscape. Newgrange in Ireland, a passage tomb built with such precise astronomical alignment that on the winter solstice, a shaft of sunlight penetrates the long entrance passage and illuminates the inner chamber for exactly 17 minutes. The Ring of Brodgar in Orkney, a stone circle built on an isthmus between two lakes on an island that was, 10,000 years ago, part of the mainland of northern Britain. These monuments did not come from nowhere. The tradition of large-scale stone construction that produced Newgrange and Carnac, and the hundreds of other megalithic sites along the Atlantic coast of Europe, extends back to at least 5000 BCE in its currently documented form, and possibly earlier. The technical knowledge required to align a passage tomb to the winter solstice requires sustained astronomical observation over multiple generations, watching the sunrise point on the horizon shift day by day across the year, marking the extremes, recording them with sufficient precision to aim a stone-lined passage at a solar event that occurs once a year. That is not beginner's astronomy. It is the product of a tradition that may have been maintained on the coast of Doggerland before the water came. The astronomical sophistication of the Atlantic megalithic tradition is a real phenomenon, documented across dozens of sites with consistent precision. The winter solstice alignment at Newgrange is not an accident and not coincidence. The passage is 852 centimetres long, oriented to within 1 degree of the winter solstice sunrise azimuth for the latitude of the site at the time of its construction around 5,200 years ago. The light box above the entrance, a separate aperture designed specifically to admit the solstice light while the main entrance is closed, is an intentional engineering feature. Somebody designed that. Somebody knew enough about the movement of the sun across the year to design a stone structure around a specific solar event. That knowledge came from somewhere. It was accumulated. It was transmitted. It did not appear fully formed at Newgrange. The question of how far back that astronomical tradition extends is genuinely difficult to answer with the evidence currently available. The submerged landscape of Doggerland is too deep and too degraded in most areas for systematic survey to reveal the kind of structural features that would confirm organised settlement. But the pattern at Göbekli Tepe, sophisticated organised construction at 12,000 years ago, built by people who appear to have arrived with their tradition already formed, suggests that the depth of the organisational tradition behind the Atlantic megalithic monuments may be similarly greater than the visible surface of the archaeological record implies. Plate tectonics is relevant here in a way that is easy to overlook. The Atlantic Ocean is still widening. The mid-Atlantic ridge is still producing new oceanic crust. The continental shelves of the Atlantic basin, the drowned margins of the rift that opened when Pangea split, are the direct descendants of the rifted margins of the supercontinent. The geometry of those shelves, their width and depth profile, determined exactly how much land was exposed during the last glacial maximum and how much was drowned by the subsequent sea level rise. Different parts of the Atlantic margin have different shelf geometries, reflecting the different histories of their rifting. The broad, shallow shelf of the Celtic Sea and the southern North Sea, Doggerland's territory, reflects a rifting history that left a wide, gently sloping margin. The narrower shelves of the equatorial Atlantic, where the rifting was more recent and the margin is steeper, exposed less land during the glacial maximum. The shape of the lost world was written by the breakup of Pangea. The civilizational implication is this: the most habitable submerged territories, the wide, shallow shelves with the richest coastal ecosystems, the most productive estuaries, the most temperate climates, are concentrated along the rifted margins of the old supercontinent. These are the places where the geological legacy of Pangea's breakup created the conditions for large human populations to establish themselves on productive coastal landscapes. These are also the places that were most completely drowned by the post-glacial sea level rise. And these are the places that are most conspicuously absent from the early archaeological record. The pattern is not coincidental. It is geographical determinism operating across geological time. Pangea's breakup created the template. The glacial cycles determined when the template was above water and when it was below. The civilizations, or proto-civilizations, or complex societies, or whatever term fits the level of organization that existed, built themselves on the template when it was exposed and were erased from the accessible archaeological record when the template was flooded. This does not mean that a technologically advanced civilization in any modern sense existed before the flood. The evidence does not support that reading. What it supports is something more modest but still significant. That complex social organization, sophisticated symbolic systems, long-distance coordination, and the accumulation of technical and astronomical knowledge across generations were all present in human societies substantially earlier than the conventional archaeological timeline suggests, and that the evidence for this earlier complexity is mostly sitting underwater on the submerged continental shelves created by Pangea's breakup. The world that was lost was not a world of pyramids and writing tablets and bronze swords. It was something earlier and harder to categorize. It was a world of people who knew their coast intimately, who tracked the stars as a practical necessity for navigation and seasonal timing, who built structures from the best available materials, which on many coastal plains would have been wood and reed rather than stone, and which therefore left no trace, and who organized themselves with enough social coherence to maintain traditions across dozens of generations. That is not a trivial civilization. By many measures, it is the foundation on which everything that came later was built. The Younger Dryas impact hypothesis adds a further layer to this picture. It is worth addressing because it connects the deep geological history of Pangea's breakup, the way that history shaped the continental margins, to a more proximate catastrophe that may have contributed to the destruction of whatever early coastal civilization existed. The hypothesis, which has been developed over the past 2 decades and remains actively debated among researchers, proposes that approximately 12,900 years ago, at the onset of the Younger Dryas cold period, the Earth was struck by fragments of a large comet or asteroid. The proposed impact sites include locations across North America, the Middle East, and possibly Europe. The evidence cited includes a thin layer of platinum group elements, spherical microspherules of melted and rapidly cooled rock, nanodiamonds, and elevated levels of iridium found in sediment layers of the correct age at dozens of sites around the Northern Hemisphere. If this impact occurred, its effects would have included immediate firestorms across large areas of the Northern Hemisphere, followed by a cooling of the climate, the Younger Dryas cooling, triggered by the injection of dust and aerosols into the upper atmosphere. The cooling would have stressed animal and plant populations across the Northern Hemisphere, contributing to the extinction of the Pleistocene megafauna, the mammoths, mastodons, ground sloths, saber-toothed cats, and dozens of other large animals that disappeared at roughly this time, and it would have been experienced by any organized coastal human communities in the affected regions as a catastrophe of sudden and total proportions. Fire from the sky, followed by cold and darkness, followed by the rapid resumption of deglaciation and the accelerating rise of the sea. The Younger Dryas impact hypothesis is not universally accepted. Its evidence base has been challenged on methodological grounds, and the debate in the scientific literature remains unresolved. But the fact that it is being seriously investigated, that the evidence for it is sufficient to generate ongoing research and genuine scientific controversy, is itself significant. It means that the scenario of a catastrophic event at the boundary of the Younger Dryas, coinciding with the apparent disruption of late Paleolithic human cultures across the Northern Hemisphere, is not purely speculative. It has a physical evidence base, and that evidence base is still being evaluated. The Sunderland hypothesis occupies a specific and serious place in the literature on early human civilization, and it deserves careful attention because it connects the geological legacy of Pangea's breakup to the question of civilizational origins more directly than almost any other regional case. Sunderland was the exposed continental shelf of Southeast Asia during the last glacial maximum. The dry land that connected what are now the separate islands of Sumatra, Java, Borneo, and the Malay Peninsula into a single continuous landmass, bordered to the west by the Indian Ocean and to the east by the shallow Sunda Sea. At its maximum extent, roughly 20,000 years ago, Sundaland was a territory of approximately 1.8 million square kilometres of dry land, larger than the Indian subcontinent, with a tropical and equatorial climate, abundant rainfall, dense forest, and an extraordinary diversity of plant and animal life. The geological history of Sundaland is directly tied to the breakup of Pangea. The Sunda Shelf, the shallow submarine platform on which Sundaland sat when exposed, is the rifted margin of the Australian portion of Old Gondwana, the southern half of Pangea. The tectonic processes that separated Australia from Antarctica and drove the Australian plate northward toward Asia created the complex archipelago of islands and shallow seas that now characterises Southeast Asia. The shelf geometry, wide, shallow, gently sloping, is the product of that long tectonic history. And it is that shelf geometry that made Sundaland so large during the glacial maximum and so completely drowned by the subsequent sea level rise. The water that covers Sundaland today is mostly shallow, between 50 and 100 metres, which means it was exposed land for most of the last glacial maximum and was progressively submerged over a period of roughly 10,000 years as the ice melted. The people who lived on Sundaland during the glacial maximum were not anatomically primitive. Modern humans had reached Southeast Asia at least 50,000 years ago, possibly earlier. The genetic evidence from modern Southeast Asian and Australasian populations carries signals of deep ancestry in this region, lineages that have been in place for tens of thousands of years, and that show the population structure of large established communities, not recent migrants. The Sundaland population at the glacial maximum was, in terms of the cognitive and physical equipment available to them, fully modern in every sense. They were people with language, with social complexity, with the capacity for symbolic thought, with the ability to navigate waterways and manage resources across a large and varied landscape. What they built on that landscape is largely unknown because the landscape is underwater. But there are indirect lines of evidence that point toward a level of social complexity that goes beyond simple hunter-gatherer bands. The linguistic diversity of Southeast Asia and the Pacific is extraordinary. The Austronesian language family alone encompasses more than 1,200 languages, spread across a territory from Madagascar in the west to Easter Island in the east, making it one of the most geographically dispersed language families on Earth. The expansion of the Austronesian languages, which genetic and linguistic evidence places in the period between 4,000 and 5,000 years ago, appears to have originated in Taiwan and spread southward and outward across the Pacific and Indian Oceans. But the populations that the expanding Austronesians encountered and partially absorbed, the older populations of the islands and the mainland coasts, carry genetic and cultural traces of a much older layer of occupation whose origins were in the exposed Sundaland territory. The seafaring capacity implied by the Austronesian expansion is itself remarkable. Building and navigating ocean-going vessels across thousands of kilometres of open water, using star navigation, wave patterns, bird behaviour, and current reading as the tools of orientation, requires a tradition of accumulated maritime knowledge that does not develop quickly. The navigational traditions of the Pacific Islanders, the Polynesian and Micronesian wayfinding systems that allowed canoes to cross the Pacific with precision sufficient to find islands that occupy less than a square kilometre, represent the apex of a knowledge system that was built up over many generations. The question of where that knowledge system began is not answered by pointing to Taiwan 4,000 years ago. The question is what was being practiced on the coasts and rivers of Sundaland 10,000, 15,000, 20,000 years ago, and whether the maritime tradition that eventually produced Polynesian ocean navigation was already taking shape in the river deltas and coastal waters of the exposed continental shelf. The river systems of Sundaland at the glacial maximum were substantial. The modern rivers of Sumatra, Java and Borneo, which now flow relatively short distances to the sea, were at that time the upper tributaries of much longer river systems that drained across the exposed shelf into the deeper ocean beyond the shelf edge. The combined drainage of these rivers produced large productive estuaries and delta systems on the outer margins of the exposed shelf, the kinds of environments that, in every other part of the world where they can be studied, are associated with dense human settlement and the development of complex social organisation. Fish, shellfish, plant resources, fresh water, easy navigation, all concentrated in one place. The Sundaland estuaries of 20,000 years ago may have been among the most productive human habitats on the planet at that time. They are now under 60 to 100 meters of seawater. The drowning of Sunderland was not a single event. It was a process lasting thousands of years, punctuated by periods of more rapid inundation corresponding to the meltwater pulses already discussed. But the final phases of Sunderland's submersion, between approximately 14,000 and 8,000 years ago, were rapid enough by human experiential standards to constitute catastrophe. The Java Sea, which now separates Java from Borneo and Sumatra, filled from the edges inward as the sea level rose, progressively cutting off the elevated core of what had been the Sunderland landmass into the islands that exist today. Communities that had been connected by land were separated by water. Trade routes that had run overland became sea crossings. The shared cultural and linguistic traditions of the Sunderland population were fractured along the new coastlines. This fragmentation is visible in the linguistic and genetic data. The populations of the modern islands of Southeast Asia carry genetic signals of an ancient shared ancestry, overlain by more recent movements and admixtures. The oldest genetic layers, the signals that correspond to the pre-Austronesian, pre-agricultural populations, are distributed across the modern archipelago in a pattern consistent with a formerly connected population that was divided by rising water. The cultural and linguistic diversity of the modern region, which is extraordinary even by global standards, may partly reflect the diversification of a formerly more unified population following the loss of the connective tissue of the Sunderland landmass. There is a tradition in the Malay world of a land called Tanah Melayu, the Malay land, that extends back into a mythological past of considerable depth. The Malay Annals, a chronicle of uncertain original date, but clearly drawing on much older oral traditions, describe a founding civilization of great antiquity that arose in a territory associated with the sea and the coasts. The Javanese traditions carry similar deep memories of a lost world connected to the sea, a world of great kings and great cities that the water eventually claimed. These traditions have the same structural characteristics as the Mesopotamian flood myths and the Australian coastal memories discussed earlier. A former world, destroyed by water, remembered in the cultural practice of a descendant population that built its identity partly around the memory of what was lost. The connection to Pangea is not merely metaphorical in this case. The Sunda Shelf is literally a piece of the old Gondwana margin, rock that was once part of the southern landmass of Pangea, that separated when Australia broke away from Antarctica, that drifted northward and was eventually partially submerged by the same post-glacial sea level rise that drowned Doggerland and the Levantine coastal shelf and the Persian Gulf plain. The civilizational story of Sunderland, to the extent that it can be reconstructed, is the story of a population living on a Pangean geological remnant, building whatever level of complexity they reached, and losing it to the water that filled the gap left by the ancient rift. The great stone site of Gunung Padang in West Java adds a specific and currently debated piece of physical evidence to this picture. The site consists of a large terraced mound covered in basalt column arrangements, traditionally interpreted as a relatively recent megalithic site of the last few thousand years. But recent drilling and subsurface analysis, the results of which have been published in scientific literature and have generated considerable controversy, suggest that the mound conceals much older construction beneath its surface layers. The deeper layers, reached by core drilling, show worked stone and what the researchers interpret as constructed chambers at depths, corresponding to ages of potentially 15,000 to 25,000 years, which would place the earliest phases of construction during or before the last glacial maximum, making it potentially the oldest known deliberately constructed site in the world. These claims are disputed. Other researchers have challenged the interpretation of the drilling data, arguing that the subsurface features can be explained by natural geological processes rather than human construction. The debate is ongoing and has not been resolved, but the site exists, the mound is real, the basalt column arrangements on its surface are real, and the possibility that it conceals earlier construction is real enough to have generated serious scientific investigation. Whether or not the most dramatic claims about its age are ultimately confirmed, Gunung Padang represents the kind of evidence that keeps the question of Sunderland's civilizational history open rather than closed. The clay is still wet when the scribe sets the reed stylus against it for the last time that evening. The lamp beside him, a shallow dish of sesame oil with a twisted fibre wick, throws a small circle of orange light across the surface of the tablet. Outside the Scribble house in Nippur, the night is warm and the stars are visible. He has been copying this text for 3 days. It is older than anyone in the city can say, passed down through scribble schools whose founding predates any living memory. A text about a time before the cities existed, before the flood came, before kingship descended from heaven the second time and the world began again. He finishes the line, sets the stylus down, and reads back what he has written. The signs say, in those days, the land was not yet, the sea was not yet, the springs of water were not yet formed, the gods had not yet been created, nothing had been named, and then, from that emptiness, everything began. He does not know what those words mean in a literal sense. He is a trained copyist, not a theologian. He knows the signs, he knows how to form them correctly in the clay, he knows the penalty for introducing errors into a sacred text. He does not know that the land his city is built on was once part of a much larger connected body of land, that the sea outside the marshes and the gulf to the south was once a dry plain with rivers running across it, that the stars he can see from the roof of the Scribble house have been used by people who came before him, people whose names are not in any list, whose cities are under the water, to navigate across distances he cannot imagine. He knows the text. The text says there was a time before this time. He copies it carefully and smooths the edge of the tablet with his thumb and sets it in the row with the others to dry. What the scribe of Nippur was copying that evening, in the 2nd millennium BCE, was a tradition that encoded in mythological language a real sequence of geological and environmental events stretching back tens of thousands of years. The formlessness before creation, the waters of chaos, the undifferentiated deep, is a consistent feature of ancient cosmogonies from Mesopotamia to Egypt to India to the Pacific. In Mesopotamian tradition, it is the Apsu, the freshwater deep, and Tiamat, the salt sea, commingled before separation. In the Egyptian tradition, it is the Nun, the primordial ocean from which the first mound of dry land emerged. In the Vedic tradition, it is the waters upon which the Creator moves. The specific imagery differs. The structural claim is the same. Before the world was the world, there was water, and the world that emerged from the water was not permanent, it was subject to return. That is not a theological abstraction. It is a geological description. The Earth has been covered by shallow seas multiple times in its history. The interior of North America, which is now a great terrestrial plain, was covered by a shallow inland sea for much of the Cretaceous period. The land that is now the Sahara Desert was, in earlier geological periods, an ocean floor. The limestone of which the Egyptian pyramids are built contains the fossilized remains of marine organisms, nummulites, a type of large foraminifera that lived in a warm, shallow sea that covered northern Africa roughly 50 million years ago. The stone that the pyramid builders quarried was once ocean sediment. The world beneath any given landscape is always, at some depth, a record of the sea. The human civilizations of the past 10,000 years, everything from the early Neolithic of the Near East to the present, have been living in a geological eye blink of relative sea level stability. The post-glacial sea level rise was essentially complete by roughly 6,000 years ago, when the sea reached approximately its current level and the pace of rise slowed dramatically. The 6,000 years since then have been, in geological terms, an unusually stable period for coastal environments. The coastlines that the Sumerians and Egyptians and Indus Valley people built their cities near have not changed dramatically since those cities were founded. That stability created the conditions for civilization to take root and persist long enough to leave the record we now study. But the 6,000 years of stability sit on top of a much longer record of instability. Before the stability came the rapid rise. Before the rapid rise came the glacial maximum with its exposed shelves and its drowned-to-come coastlines. Before the glacial maximum came earlier interglacials with sea levels higher than today, the last interglacial, roughly 120,000 years ago, had sea levels approximately 6 to 9 meters higher than the present, which would have flooded significant areas of modern coastal land. And before all of that, stretching back through the full Pleistocene and into the Pliocene and Miocene, comes a record of climate oscillations, each one reshuffling the geography of habitability, each one creating and destroying the coastal landscapes that human populations and pre-human population depended on. The civilizational story is not a story with a single beginning. It is a story with many beginnings, most of them erased. each time the climate stabilised and the sea level held steady, and the coastal ecosystems recovered from the disruption of glaciation, the conditions for complex social organisation reasserted themselves. People gathered on productive coasts, built what they could build, accumulated knowledge and tradition, and passed them on. Some of those accumulations survived long enough and reached sufficient complexity to leave permanent traces. Most of them did not. Most of them were interrupted by the next climate shift, the next sea level change, the next episode of environmental stress, and the knowledge that survived each interruption was compressed and encoded in mythological form, in flood stories, in cosmogonies of chaos and order, in lists of kings who ruled before the flood, and carried forward by the survivors into the next beginning. The Sumerian king list is, from this perspective, something more than a political document. It is a memory device. The impossibly long reigns of the pre-flood kings are not meant to be taken as literal biography. They are placeholders, signals that there was a world before the flood, that it was organised, that it had a sequence of authority and governance, and that its duration was immense by human standards. The numbers are chosen to convey vastness, not to record specific lengths. What the king list is preserving is the structural memory of a world that existed before the catastrophe, expressed in the only language available to a scribal tradition that did not have the conceptual tools to describe geological deep time. The move from the pre-flood world to the post-flood world in the king list corresponds, in geological terms, to the move from the drowned coastal world of the late Pleistocene to the emerged, stable coastal world of the Holocene. After the flood swept over, after the sea level rise completed its work and the coastline stabilised, the cities of the historical record were built, Eridu first. The mound of Eridu, excavated in southern Iraq, shows occupation layers going back to approximately 5,500 BCE. The oldest levels filled with a distinctive painted pottery that appears apparently fully formed at the base of the sequence, with no obvious local precursor. The Eridu tradition does not look like it grew from a local beginning. It looks like it arrived carried by people who brought their pottery tradition and their architectural practices with them, from somewhere that is not visible in the currently accessible archaeological record. Where they came from may be the Persian Gulf Plain. During the last glacial maximum and well into the post-glacial period, the Persian Gulf did not exist as a sea. It was a dry basin, crossed by the combined drainage of the Tigris, the Euphrates, the Kharin and other rivers, creating a fertile river-valley environment that would have been among the most productive habitats in the Near East. This Persian Gulf oasis, as some researchers have called it, would have been an ideal location for the development of complex settled societies. Fresh water, fish, game, rich alluvial soil, temperate climate moderated by the surrounding highlands. As the sea level rose and the Strait of Hormuz flooded and the water moved northward into the basin, the populations of the Gulf oasis moved with it, retreating northward ahead of the rising water, eventually settling at the head of the Gulf in the marshes and delta plains of southern Mesopotamia. Eridu is at the northern edge of what was once the Gulf oasis. Its founding population may have been the last generation of Gulf oasis people to make the move inland before the water closed behind them. If this reconstruction is correct, the founding population of Sumerian civilization was a refugee population from a drowned world. They carried with them the traditions, the technical knowledge, the pottery styles, and the social organisation of a society that had been developing for thousands of years in an environment that no longer exists. They built Eridu on the edge of the new shore, and from Eridu grew Ur, and Uruk, and Nippur, and Lagash, and the rest of the Sumerian city system. And from the Sumerian city system grew everything that followed: the writing, the law, the mathematics, the astronomy, the mythology, the cosmogony that the scribe was still copying in the lamplight of Nippur 2,000 years after Eridu was founded. The chain that connects the scribe of Nippur to the coastal populations of the Persian Gulf oasis and the Gulf oasis populations to the earlier coastal traditions of the wider Indian Ocean world, and those traditions back through the drowned landscapes of the post-glacial flooding to the organised communities of the late Pleistocene coastlines, is long, and most of it is invisible. The links are broken by the sea, by time, by the selective survival of durable materials in dry places, but the chain is there, implied by the convergent evidence of geology, genetics, mythology and archaeology. And at the far end of that chain, 200 million years back, is the event that created the template on which all of it was built. The splitting of Pangea, the opening of the ocean basins, The creation of the continental shelves that would become, in the long fullness of time, the stage on which the human story played out. The scribe finishes his work. He covers the tablet with a damp cloth to keep it moist until morning, when it will be checked by the head scribe and then fired in the kiln to make it permanent. He goes out onto the roof of the scribal house and looks at the stars for a few minutes before sleeping. He does not know that the marsh to the south of the city, where the reed boats go in the early morning to fish, was once dry land. He does not know that the land was once connected to a coast that stretched far to the south, all the way to a sea that is now closed. He does not know that the stars he is looking at have been used for navigation by people whose names are nowhere written, whose cities are nowhere above the ground for longer than any number he has learned to write. He knows the text. The text says there was a time before this time. That is enough. This is a good place to rest. The full story of how Pangea's breakup shaped the geography of human civilization cannot be told in 2 hours, and this documentary has not tried to tell all of it. What it has tried to do is trace the thread from the geological event itself, through the long reshaping of the Earth's surface, through the glacial cycles that repeatedly exposed and drowned the productive coastal margins created by the rifting, through the archaeological and mythological evidence for complex human organisation on those drowned coastlines, and up to the threshold of the historical record where the flood survivors built their cities and wrote down what they remembered. There is much that remains unknown. The submerged continental shelves have not been explored. The oldest layers of many sites remain unexcavated. The full implications of genetic data for human prehistory are still being worked out. The boundaries of what happened before the flood, in the geological sense of that phrase, are not yet drawn with any confidence. What is certain is that the ground moves. It has always moved. The civilization that exists today is built on a surface that was once joined to every other surface on the planet, that tore itself apart over 200 million years, and that has been rearranging the conditions for human life ever since. Every coastline is temporary. Every city built near the sea is built near a margin that the planet created and that the planet can reclaim. The scribe of Nippur knew this, in the language available to him. He copied it carefully into the clay, and the clay survived, and here it is. If this documentary gave you something to think about as you drift off tonight, a quiet click on the channel means more of this kind of content keeps coming. Sleep well.